Hi guys, so let's make a start. In any distributed platform like microservices or global systems, we cannot achieve strong data consistency. Not strong data consistency, low latency, and availability all at the same time. Over the years, or since the 60s, we've been working on different methods of dealing with these problems. And microservice is just one of those areas that have to make a trade-off in design based on the needs of our end user. So introduce myself. My name's Steve Heasman. I am a lead software engineer at Cubic. Been an engineer now for around, I think 15 years officially, after studying computer science at Teesside Uni. But I was like a lot of us at this stage, kids, and we were trying to hack everybody. We were, it was lots of fun before we did the training. My career has included insurance, oil and gas, R&D, ITS, which is transport markets, some really cool projects over my career, including CT scanners for oil pipelines under the sea and lots of big data projects. So I lead a team of engineers working on systems like we're going to talk about today. Been building microservices now for about 5 years in some form or another. So we thought I would try and share some of my findings with you today. I'm going to try and make this not too technical, which I have a tendency to do, being as this is what I do. So we'll try and keep it not too technical, but also I'm sure you're all aware microservices is a pretty complicated subject. So we'll see how we get on. Feel free to ask any questions. Fine. So just a quick introduction on what we're doing. So we're going to look at a problem definition, eventual consistency, database considerations, tools, release processes. It's basically a collection of things that have been a problem or something that we've learned on my journey. They're not probably in exactly that order, so it's one of those. So I work for Cubic. So Cubic is, as you can see, is very software-oriented, technology-driven market. We do everything from transportation, defense, and mission systems. It's quite a large company, I'm sure you can imagine. So we have, I think, founded in 1951, 1.5 billion sales last year, 6,500 people. We are spread all over the world. Mission systems and our global defense systems, a lot of that work is over in America. Cubic Transportation Systems is kind of the UK side of it. So the UK, the CTS business, I mean, if you have been through the London Underground, if you've been through anywhere in America with big underground systems like Boston, anything like that, those kind of systems, you've used our software in one way or another, or our hardware. So you can see there we have 35 million passengers using our systems, 500 million revenue. Yeah, I mean we do everything from Transport for London, Transport for New South Wales, kind of, we have a vast set of customers, and there's everybody needs a good map in their presentation, I've been told. So there's my map, customer locations all over the world, fantastic. And then a couple of images of some good stuff that we work with, a lot of payment systems, gateways, tracking, lots of innovation, all very technical. So why do we care about great software architecture? It's always a good question. So one of the things over the years is realizing that software architecture is our foundation of our software system. Like all the thumbs of engineering, the foundation has got a profound effect on the quality of what is built on top of it. And microservices, it couldn't be any more true. If you get your architecture wrong, then you find some real failures later on, and normally those failures don't come to light until you're you're out in the ethos, and you've got customers using your systems. So it's very important in terms of our successful development, and obviously eventual maintenance of our systems. What we're going to do is we're going to follow the iterations of a product. We're going to look at where it went wrong. We're going to look at the microservice ecosystem. As we all know, everybody here will know that the microservices are quite complicated. There are 3 million tools absolutely everywhere, and I kind of see it as a bit of a recipe, if you like. Every engineer will come up with their own version of how to do this. This is just a version of doing it that I'm quite passionate about. So I want to try and share a few bits, share some bits with you. So we'll try and do this a little bit different. We're going to work on a problem definition, and we're going to work our way through where these problems lied and what this particular customer got to. So we're going to do this in a simple sense. We've got a new product manager who's arrived at the business. He's been granted the dev team for a new project. The new project is a new website. Website is going to have blogs, products. It's going to be their new flagship order portal. Needs to be able to handle a large amount of customers. So the manager and the project manager set away designing and working out what we're building. Fantastic. Great first start. So like everybody, and 10 years ago, 5 years ago, this is where we'd all be. We would have wrote our own probably .NET Core or .NET Framework MVC app. We'll go into our meetings. We're talking about, well, it's mobile optimized because we've used Bootstrap. It's .NET Core. It's we've got Swagger APIs. Our APIs on our front end are separated. We've used Nugget packages where we have to. Fantastic stuff. Yeah, we've all built them. We've built them for years and years and years. The problem over time is as your product becomes more vigorous, it's expanding. It's got more and more data in there. We saw on there you're using a database first. You've got an anti-framework model. It gets very difficult. So your manager is going to come to you, and he's not going to be happy. He's going to be talking about, look, the Jira backlog is ridiculous. It's filled with defects. I can't get enough developers around the code. We've got latency at one point. Any developers around? That we've all had some point we've used SVN. If you're a developer, you know what I'm talking about. Code base gets so big, and your defect list just grows. And you've got everybody wanting more and more things around. So Monday morning, we've got a new manager. They've been reading the Gartner 2020 tech reviews. It could be any. There's so many. I've put Gartner because that's the main one. And it's all about microservices, and then you've all seen it. It's been talked about quite a lot for the last couple of years. Write your services in any language. They're loving it, absolutely loving it. You're probably just sort of waking up thinking, okay, we better get on Google and find out what this is all about. It's fine. So let's look at O'Reilly did a survey on the microservice adoption, and I thought there was some great points in sort of raised. Little things like a minority, under 10% reports. And this was out of 1,500 businesses that were doing this. Under 10% reported complete success. 54% described as at least mostly successful. 92% said there'd some success. So only 10% of the customers that have tried to adopt microservices, and it probably would have been at an early stage, it's difficult, very, very difficult. Only 10% got a complete success. That's quite worrying, especially with the amount of money. If you imagine how much money we spent on our IT systems. If it's a project or it's a product, whatever you're building, that cost is it's a lot of money. You know, you get a few engineers working on a project, those hours rack up. So yeah, it's quite worrying that you know, that it's a mixed review. 28% of respondents say their organizations have been using microservice for the last 3 years. More than 3/5 respondents been using it for a year or more. So it's quite new. I think that's you know, people are starting now to adopt it. I think there's a lot of people, a lot of businesses kind of have the idea that they're going to use it, and their plans are to use it, but a lot of people probably don't have a great deal as to, you know, how is that going to work. Interesting. So almost 1/3 of respondents say their employers are migrating or implementing majority of their systems, over 50% using microservices, and that's great. You know, but I think, you know, that there are caveats. We shouldn't, and it's quite important to make sure that we don't use microservices for the sake of it. Microservices solve certain problems. If you rush to implement a microservice and you don't have the people around you that are good at doing it, or you don't have a design or an architecture plan, it can get very, very messy. So don't use microservices if you don't need to. There's a reason for using them. You know, it's quite interesting. Respondents who use containers to deploy microservices were significantly more likely to report success than those who didn't. And I would 1,000,000% agree with this in every way. It's all containerization now. Everything we do is it's Docker or it's Kubernetes or it's some kind of containerization. I haven't found any real reason why you wouldn't use containers. I am a fan, but then, you know, essentially I'm a developer. So I think most developers love the fact that you can knock up you know, you can run up a Docker Hub C container within minutes, or a RabbitMQ container in a minute, and you know, and that is a huge win. I think what this O'Reilly report kind of shows us, you know, when you're looking at you know, the sort of rates, nearly 10% have just failed. And that really worries me, that microservices, people are going to get really pushed off that, because 10%, when you think of the money that have gone into that, you know, that's crazy. What I'm going to do is I'm going to show you, yeah, I'm going to show you a video. It's a very quick video. It's a YouTube video. There's a reference on the top, and I thought it was exactly how, at some point in time, big microservice architecture, they have these conversations, and I think it's definitely something to share. Now let's see if you guys can hear this. Can everyone hear that? No. Okay. Fantastic. Let's see if I can figure it out. It is very funny, Adrian. You're 100% right. So, I mean, I'll explain it to you. It's fine. We don't have to. We don't have to play it as such. And so the whole point of this is we have a normal microservice engineer. He's probably someone like me in a lead position. The product owners come in. They've asked for something as simple as a date of birth on the settings page. Whoosh. And the product owner wants to know, you know, he comes in, he's like, right, I've asked you for a date of birth on the settings page. Why is that taking, why is that going to take you 3 years? And so the engineering question here is, you know, he goes through the whole thing. It's this service talking to this service, and then we've got to use these, we've got to use this over here, we've got to use that to that. And basically the engineer is having a total breakdown. And it's a great example of how you can do microservices badly. Your microservice architecture can be complicated, but it also doesn't need to be. You know, if you design these correctly and you architect them correctly and you have the right principles around you, 100%. So let's we'll skip the video. We're thinking on our feet here, guys. Don't worry. Okay. Cool. We can't really talk about microservices without having a quick sort of skimmy over them. I'm sure you've all come across microservices. You'll hear them. I'm sure there's other talks about microservices or something similar. So the key principle of microservices is simplicity. Applications become easy to build, maintain when they're split into a set of smaller fragments, and that's, you can't argue with that. Power to create, developers more independently, work autonomously, and make technical decisions quickly in smaller groups. That is true, but I'm going to tell you, and there's a few reasons as to why that could also be a negative as well. Every microservice can be written using a your service. Again, it's a great added benefit, but in reality, we're not Google. We don't have 4,000 developers and 8 different programming languages. We've probably got a team. Cubic is quite large, but we're still, the CTS engineering department is still probably 30 people. What I don't want is, I don't want a project where I've got 4 microservices. One's written in Go, one's written in PHP, somewhere else is written in any kind of language. Then I have a problem where I can't support it. Developers move. So you need to make sure that, yes, you can use any technology or service, but you don't have to. Productivity and speed, decomposing applications into management services that are faster developed, fantastic, yep. And then build products and not projects, and 100%. At the end of this, I'll probably have to give you a link rather than show you, because I will try and figure out the sound, but I do want to show you a success story of one of the last microservices that we wrote, and it's a very large microservice, and it's released, it's running at the moment for New South Wales in Sydney. So we'll show you that at the end. So if you get these things right, they work really well. So let's say what the first version of our traditional application didn't work. It worked. It was fantastic. It was all one app, and you've put it in Azure. It's in the cloud. It's on one of those app services. It's relatively cheap. You've got an Azure server there, a SQL server, choosing a database first model. Fine. You've got to the conclusion that it doesn't give you what you want. Your manager's read all of the different buzzword magazines, and you've come to the conclusion microservices are the way to go. So let's go through and see where we get to. So the first iteration. And I was going to say at this point, it doesn't really matter what the problem definition here is. We've come to the conclusion we have a very large system, and we need to we need to scale out this system. We can't do that in a traditional application. So the decision's been made. We're going microservice, which is fantastic. And on paper, doesn't that look beautiful? Very, very pretty. So this uses and it's something that a lot of people do. So we use a CQRS microservice design pattern. There are errors in this, of course. This wouldn't be a presentation without. Can anybody spot the first of all the very obvious problem? And it's always interesting to see whether or not people see it like we do. Can anyone see the problem straight away? So I can't even see you guys talking. Hang on a second. Yes, got some engineers in the room. Yeah, totally. The database is a major problem. So let's talk about why. I guess we'll fly over this. So huge issue. You've got one database in the center. So you followed, and you've got your source code into these nice little microservices. They're fantastic. You followed CQRS. You've done domains. So you've done DDD. You've worked out all of your domains and all of your bounding contexts. You've got these lovely services, but the one thing in the middle, and the easiest thing you didn't want to change, was the database. And there's reasons people do this. A lot of the reasons is around the fact that you had originally a database first model, or you don't have a code first approach. You've never ran with code migrations. You've gone with this EF framework, and you've just bolted it into everything. So there's certain reasons that we don't do that. We're going to go across a couple of them, but the main reason, other than the technical reasons, is it encourages your engineers to cheat. It's that simple. If you're trying to communicate and you're going across services, if you've got one monolithic database underneath, you're not getting any of the benefits of microservices. I know it's probably a wrong thing to say. You're getting some of the benefit, but you wouldn't believe this. There's a lot of companies that have exactly this, and that can be quite complicated. So let's look at a really quick example, because I'm just spotted the time, and microservices is way too big. So let's say we've separated out. We've managed to get a user team and accounts team. We've got different features. Unfortunately, it's one monolithic microservice, one monolithic database underneath. So as soon as the accounts department, the account service decide that they want usernames to be longer, they want to change the data type on any kind of enum, it could be anything. They've made that decision. They've updated the EF framework. They've re-released their feature, because that's what we want to do. Instantly, the user service and the order service are out of sync. They don't have the right EF models. And then what we find is, the whole thing is it's just going to fall over. And again, this is something that you may test and find, or what you may find is that this makes it through to production. And then you've got to answer those questions as to why that happened. So let's say, for example, you managed to get everything working, everything's gone past, you're flying, and then again, developers will love this slide as well. Yeah, the Power BI monster, he's in. And this again happens all the time, because there'll be some kind of ops conversation somewhere where we've not considered ops, and someone's gone, oh, we need a big dashboard. Okay, great. So someone's because we're low on money by this point, we've built all these systems, someone's going to create a Power BI dashboard because they're cool. Unfortunately, they put a great load on your operational database. You should never be running reporting from your main database, even if it is one or you've got many. It shouldn't happen. So again, Power BI is a monster, which is why he's got some evil eyes there. I quite like that. So basically what we've come to is a single database it doesn't work. Okay, so we need to incorporate eventual consistency into what we're doing. And I'm going to try and go through, because I took a bit too long to begin with, so I'm going to try and fly through some of these guys. I am around if people want to chat about it afterwards, though. So the difference in a consistency model is quite straightforward. A strong consistency model. So let's say a user is going to update their address. They update the feature. Okay, so the feature is updated. Users update their address. Now the accounts feature also needs that address. Strong consistency would be waiting for accounts feature to also get the update. So by the time you get back to, and we'll say it's 0.4, it's because everything is standard, everything's been updated, you're fine. The eventual consistency model is obviously the opposite of that. So you will update the user feature, which you should do. You return your 200 OK back to your UI, and then eventually the accounts database will receive the same update, and that's where we're trying to get to. So let's take a look at how it should be done. So we've taken those three features. Okay, the new eventual consistency way is they've all got their own database. That database can be in any format. Again, these databases, sometimes you could even use database first if you really wanted to at this stage. I wouldn't suggest it, but it's possible. What you now have is a micro UI component, because we've just we've created a load of microservices. There's no reason why a UI can't create micro components as well. And what I found in a lot of my projects is there's a lot of different frameworks that can work this way. So in the last one, and this particular one, it was Angular. Fine, no problem. You've got to use a busing technology, because everything is at this stage, we're event driven. So we've got our micro components in the web UI. They have submitted a request, so we're going to call it a command at this stage. The command has come through to the user feature. The user feature has done whatever it needed to do. It has updated the address as we've expected. The user feature then returns back to the customer, returns back to the user component and says, we're done. I'm happy. We've changed your address. On succession of adding the updated address, what we find is that onto our bus goes a user updated event. That user updated event is then picked up by any handler or consumer that is listening. If the accounts feature, for example, is interested in the user address because it needs to update its invoices, it doesn't want to have to ring or go and talk to the user feature every time it needs to know any bit of this information. So it's keeping track of the bits of data from the user feature that it needs. Order feature, exactly the same process. You know, it's got some addresses in there. It's tracking that data and it needs to keep track of that. So it updates its system as well. Now, there's multiple ways of doing this handling. You know, CQRS is a lot of it. A lot of people would then do HTTP calls across the top. And one of the wins here, I think, is the way busing technology has changed. We on this occasion, you know, I've sort of said we'll use mass transit and RabbitMQ. RabbitMQ is fantastic because it actually holds up to 2 gig per message. I don't know, you wouldn't need 2 gig per message, and there are probably better patterns for organizing, you know, your data pipeline as well as your event pipeline. But these are options, and we're now looking at, so if the user feature is updating, it's just an address, that model can be passed with your event. So the accounts feature and the orders feature, they don't need to ring up. You know, they come through the user features API to ask for information. They don't need it. You know, it's there in the object model. But this again is dependent on who you use and what busing technology you're using. The interesting point here is that the interesting point here is that this is a different thought process for developers. And when I talk thought processing, you know, we're taught at university to follow the rules of normalization. You know, a database can't, you can't duplicate user data in the accounts feature and the orders feature. You're duplicating data. That's not third form normalization. You're breaking all the rules. And that is the original way of thinking. That was how we were all taught. That has now changed. Storage is cheap. Databases are cheap. And the wins that you get from the latency, you know, for example, the accounts feature, if we were to query the accounts feature and we were to pull up a list, and that list included the, I don't know, the postcode from the address, that list is now quick. It's nice and fast. It had all the data it needed. It was stored in its own optimized way in its own data set. Yes, there is a chance that a couple of milliseconds before, the user feature may have only just updated the address, and the data that you get in the accounts feature is out of date. The trick here is to realize that some of these processes, they don't need to happen immediately. The accounts feature isn't going to send out invoices in the next minute. But even if it does, if it sends them out and it's got the wrong address on there, it's limited. It's pretty small. The user feature is sending messages on the bus, but the bus is now able to deal with a lot faster throughput than it ever was. So RabbitMQ, you know, they mass transit are claiming, you know, that they can deal with, you know, near on 100 messages a second, 100 million messages or million messages a second. That's crazy. And if your pipeline is able to, you know, if you've got so many orders going through your system, then you're doing really, really well. You know, but it's fantastic. CQRS microservices. I'm not going to go into CQRS. It's another pattern, and I don't have time for it. So we end up with another version, and this other version is it's a lot more stable. You know, we're using things like, and on this particular one, it's using Docker Swarm. Redundancy, fantastic. It's used .NET Cores for its services, fantastic. They can now be deployed on Linux machines instead of having to use Windows. You're using NuGet feeds, fantastic. They, you know, instead of a microservice. So, for example, if the user service needs to have information from the order service, for example, It just needs to pull in the common library in through NuGet, and you've suddenly got a load more access to that data. You'll see here that MongoDB is there. So I think in this example I was using Azure SQL Server. MongoDB is for the persistence of our data. So, and I'm sorry about how quick this is. I'm disappointed myself here, but the problem that our microservices and CQRS are stateless. They have no state, but unfortunately that doesn't work in the real world. I can't, for example, I can't, for example, go to buy some shoes and we say, yeah, customer can have the shoes, but then later check if we've paid the bill, then later check if the stock is there. That is just a rule for failure. So at some points we do need persistence. Now, in this particular example, it's a mass transit with a MongoDB state machine persistence. Fantastic. So now what we find is your Saga will create a first transaction. So let's say that first transaction is to hold stock. Fine, you've now got that stock. It's held. It's in a provisional state. The next bit could be, when is delivery? Can we get the delivery on that date? The next event could then be a payment gateway. The loads of different. It's essentially one big transaction. If any of those points fail, then they all fail, and it'll roll back. And that's how we get that persistence for the bigger transactions. But with things like mass transit and MongoDB persistence, this stuff's a lot easier to do. It used to be really difficult to think about this in the terms of, we've got to create transactions, and, it's quite a difficult thing across multiple services all over the place. We're there now. You can do this stuff relatively easy. We've got examples of how to do this stuff relatively easy. Tooling is a nightmare. So I'll be honest with you. We have so many tools around now that it's crazy, absolutely crazy. So for this example that we've sort of kept it straight. So this was the tool set. So there's a SQL Server sat there. It's using eventually it'll be using a code migration database. You got to think about those release processes. Remember, if you release version 1 and then 300 versions later you try and release version 2. You need to be able to do all of those steps, so your database should be, where appropriate, should be able to be released and updated. Not so difficult for the document DBs, because you're just, you're going to update your code. So this is using a RabbitMQ as a busing technology. It's load balancing everything using Trafic. So Trafic load balancing, because you could end up scaling out your consumers. If you scale out something where you let's say you got a UDP client, it's consuming all of that data. The UDP client needs someone to save it into different data stores. You want to be able to put that on a bus and be able to scale out the consumers behind it. And that's what this is. Swagger is a must. I'm not going to re-preach. You guys all know what Swagger is. So you get automated API clients. Angular, because it kind of suits the modular way that we like to work. And then obviously in this case, we've used Seek and Portainer. Again, 2 services from Docker Hub we can pick up and run within minutes. Half of this architecture you can configure and run within minutes. And that's what this is all about. We are running out of time, but let me just do a quick considerations here. You have to consider the different environments that you code in. So for example, when you're coding locally, you can't be using an Azure service bus or an Azure premium bus, or those you may use those in a production environment, but you're not going to use them locally because it's just too expensive. So you do need to consider. It could be, for example, that you abstract out your busing technology and your queue technology. You abstract that out. Use locally. Use RabbitMQ. It's free. When you get into a production environment, scale up. Let's go. End service bus, Azure premium bus, guaranteed delivery. And you change it based on where you're at. When you're in development, you need to develop. It's cheap. It's yes, you need it quickly, but when you get into your dev environments, they're probably a completely different cost model, different abstractions. The whole thing is different. So you've got to consider those when you're working. Release considerations. I think we touched on this before. Release pipelines are just as important, but you need to agree a lot of things up front. Agree your branching technologies, agree how you're going to do your releases. Make sure that your release processes work on an individual basis. If you're releasing and your release is one release at an entire time, that's a monolith. and you've lost a lot of the benefits from using microservices. Don't do what everybody does. Your engineer will come to you and he'll say, hi, I can do it this way. And your product owner will go, oh God, really? That's going to be taking what, another 3 sprints? Oh, I could do it this way. Don't do that. Because the product owner is going to take the path of least resistance. He's got different objectives to you. He's going to want to get your product out to the customers. You want to make sure that this doesn't fall over in 5 years' time when you get to scale out. Really important. I was going to show you this. I will give you guys in a link because it's a success. So it's a success it's our latest release. You can find it on YouTube. It's I believe it's called Cubic ICMP, something along those lines. I'll make sure that you guys have got it anyway. On a summary, have I got a couple of minutes or not? Let me have a quick look, guys. Yeah. From a quick summary, look, I've done microservices for a long time. I've been developing for even longer. Architecturally, microservices are everything. I love them, but you need to make sure that you're doing it for the right reasons. Your business to match to why you're doing it. If you try and do microservices and you get it wrong, you're not going to find out until you get to that scale up, till you get to production. And then you get latency, you get problems. I believe there is enough really great tools out there for eventual consistency to be the winner across that microservice. Where you need to use sagas, you need to use some kind of persistence layer. Fine, there's loads of different ways of doing that. But really, really important that you get the architecture spot on. You design, even if you use different products, different technologies, which you can do, you've got to make sure that they understand the process, understand the architecture. It's all got to come together at the end of the day. I'm sorry that was rushed, guys. I really am. I'm happy to stick around if anyone wants to communicate or talk on the polls or etc. Was supposed to ask you if there was any questions, but we seem to have run out of time. Thanks very much for having me. Thanks, guys. It was a little bit nervous, I'll be honest. Yeah, it's quite a difficult thing to try and get into 40 minutes microservice architecture, but it's just between us, we need to learn enough and come together in these great talks. Thank Chris. These great opportunities for us to learn from each other, because microservices, there's not many people that go out there and know the whole lot on their own. So as a group, we're able to teach each other about these different bits. Really, yeah, really love these kind of things. They're great. Thanks, Liz. Yeah, you're right. We like, there's a lot of buzzwords in microservices. There really is. Yeah, totally. We've all done it at some point. Don't feel, it's that migration, isn't it? We try and migrate from our monoliths up to microservices. It's a little bit daunting. If you manage to architect that really easily, get that down on paper, sit down with some people that know about this stuff. It's the different mentality. So you're dealing with a different mentality to how we were traditionally taught, and that's different. It's quite a tough thing, but once you get past that and your engineers understand, you're not duplicating data. It's a different transform set of data. They've got their data how they want their data. Just concentrate on your data. And it worked great. Thanks, everyone.